Hello, welcome back to ASVAB Roadmap. In this video, we're going to talk about factors, multiples, and prime numbers. So let's start with factors. Factors. In order to determine the factors of a number, find the pair of positive integers which can be multiplied together to produce the number that is being factored. Start with 1 and the number itself, which are always factors of any integer. Then examine 2, 3, 4, and so on, as shown in the example of finding factors of 36. Examining the two columns show that factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. When creating the list of factors, as soon as you reach a factor on the left, which is equal to or greater than a factor already listed on the right, you can stop, since you're about to start repeating factors. In this table, there is no need to go higher than 6 because any number greater than 6 that is a factor of 36 is already in the right column. Multiples. Multiples are in a way the opposite of factors. For instance, in the example before, 1, 2, 3, 4, 6, 9, 12, and 18 are factors of 36. Conversely, 36 is a multiple of 1, 2, 3, 4, 6, 9, 12, and 18. If you become confused between the term factor and multiple, you can remember that multiples are larger because you can produce them by multiplying. There are finite numbers of factors of any number, but there are an infinite number of multiples. Prime numbers. Prime numbers, by their very definition, cannot be multiples of any integers other than 1 and the prime number itself. However, prime numbers can be factors of other numbers. 3 times 13 equals 39. 3 and 13 are prime numbers, but 39 is not because it is a multiple of 3 and a multiple of 13. A number's prime factors are factors that are prime. The prime factorization of a number is the number expressed using multiplication containing only primes, even if some of those primes repeat. To determine the prime factorization of a number, keep dividing by prime numbers until you can no longer divide because you are left with only prime numbers. For example, let's find the prime factorization of 168. Since 168 is an even number, the prime number 2 is a factor of 168. 168 equals 84 times 2. 84 is still an even number equal to 42 times 2, so 2 is a prime factor for the second time. 42 is still an even number equal to 21 times 2, so 2 is a prime factor for the third time. 21 is the product of 3 and 7. Since these are both prime numbers, the process of finding the prime factors is complete. An efficient way to determine the prime factors of any number is to use a tree, as shown below. Based on the above operations in tree, the prime factorization of 168 is 2 times 2 times 2 times 3 times 7. All the prime factors, including repeated numbers, must be listed because the original number is the product of all of these numbers. Prime factorization can be a useful tool to help you answer some questions on the ASVAB. For instance, if you need to find the greatest common factor of two integers, break down both integers into their prime factorizations and multiply all prime factors they have in common. This can be helpful when you need to reduce a fraction because you can find the greatest common factor and then divide the top and bottom of the fraction by that number. If you need to find a common multiple of two integers, you can just multiply them. However, in other cases, you may need to find the least common multiple. You can use prime factors to efficiently identify least common multiples. Alright guys, that was factors, multiples, and prime numbers. In the next video, we're going to discuss divisibility. I'll see you guys there.